This video is for page 132, starting with PCLFI for uh, figuring out the geometries for molecules with expanded octets. Now, if you want to look onto page 133 as I do this, this kind of goes through some examples on page 133, kind of like a little bit like how to draw them and like to figure out the geometry. All right, so anyway, the first thing you want to do is figure out the valence electrons in PCl5. So P, if you look up P, it has 5 valence electrons, phosphorus, and chlorine has 7, but there's 5 of them, so that's 35. And so 35 plus 5, that equals 40. So I'm going to put P in the middle, and I'm going to hook a Cl, 5 Cl's around it. 3, 4, I'll just put one down here at the bottom. Okay, 5. And then you fill out the octets for the outside atoms, give all the outside things should have 8 around them, except unless it was a hydrogen. Okay, and then you count, there's 6 around these, but 1, 2, 3, 4, 5, so that's 30, 32, 34, 36, 38, 40. Okay, so when your picture matches your number here, don't add any more lone pairs. So that is the correct structure. Now, the thing is, in order to get these shapes, it's really hard to visualize the shapes with the geometries or the shapes by just looking at a Lewis structure or even looking at a model. So the best way is to memorize it. That's the way that I found. So whenever you have a central atom and it has 5 electron domains around it, so if you want to count the 5 electron domains, well, I'll do it in red here, maybe. 1, so there's 1 there. 2, 3, 4, 5. That's a trigonal bipyramidal. So it's called trigonal bipyramidal electron domain geometry. But if each electron domain has an atom hooked to it, the geometry is also called trigonal bipyramidal. So trigonal bipyramidal is when there's 5 domains with atoms attached, okay? 5 domains, 1, 2, 3, 4, 5, and they each have an atom attached. Okay, let's do SF4. So sulfur has 6 valence, fluorine has 7, but there's 4, so that's 28, and that's 34 total electrons. So we'll put sulfur in the middle, and we'll put fluorines on the outside, 1, 2, 3, 4, and then you put 8 around everything here on the outside. Okay, and then you count and you see how many electrons you got total. So there's 6 on each. There's 4, 24, 26, 28, 30, 32. I have 2 more electrons. So when you have extra electrons you need to add, you'll always add those to the central atom. And so there that gives you 34. Now, if you look, you still have 5 domains. 1, 2, 3, 4, 5, counting that lone pair. But whenever you have 5 domains, now this is how my brain does it, minus 1 atom. In other words, there's like 1 atom missing compared to this one up here. So there's still 5 electron domains minus 1 atom. You end up getting a geometry called T-shaped. And you would be able to see that, or no, that's not T-shaped. What am I doing? That is called seesaw. And when you build the model, which we'll do in a little bit later, you'll be able to see that. All right. Now let's do BrF3. So bromine has 7, and then fluorine has 7. So basically 7 times 4 is 28 electrons. You'll have to show. So we'll put Br in the middle, and we'll put F, F, F. We'll put 8 around everything on the outside anyway. I just do the outside first. This is how I do those. And then I count, there's 18, 20, 22, 24, 26, 28. We have to add lone pairs until we get 28. add the lone pairs to the middle. Now we'll count the electron domains. 1, 2, 3, 4, 5. Okay, so we still have 5 domains. So 5 electron domains, but we got like 2 domains don't have atoms on them on the central pair. So minus 2 atoms. So 5 domains minus 2 atoms. That geometry is known as T-shaped. We're going to practice this in a little bit here with the model kits. Okay, let's do this next one, XeF2. Okay, Xe has 8 valence, and then F has 7, but there's 2 of them, so that's 14. So that's 22 electrons your picture needs to show. So we'll put Xe in the middle. We'll put F on this side. We'll put F on that side. We'll give 8 to everything on the outside. Okay, so 2, 4, 6, everything has 8 on the outside. But the middle one, we'll just count to figure out how many lone pairs we need to add. So we got to show 22 altogether. So we got 6, 12, 14, 16, 18, 20, 22. Okay, now if you count the domains, there's still 1. Oh no, don't count the domains I'm only on the central ones. 1, 2, 3, 4, 5. So there's 5 domains on the central atom. Okay, so that's kind of like trigonal bipyramidal, but we're going to be minusing 1, 2, 3 atoms. Minus 3 atoms. So having 5 domains, minus 1 atom is seesaw, minus 2 is T-shaped, minus 3 is linear. Okay, we're going to practice memorizing this in a second. Okay, let's go to the next one here. So the next one is SF6. So you would have to count up the valence. So that has 6, and 6 times 7 is 42, plus 6 is 48 electrons that you would have to show, I think, here. 36, and so, anyway, let's count. Okay, so then we'll put S, and we'll go F, 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 there's 3, F, 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 we'll put 8, or well, these will all satisfy that. The outside atoms are going to always satisfy the octet rule. They'll have 8 on them. It's just the central one will not. So my dots don't show up too good, but that one doesn't have 3. But anyway, all right. So then if everything has 6 on it, kind of lone pairs, 6 times 6 is 36, 38, 40, 42, 40, let's see, 36, 38, 40, 42, 44, 46, 48. Hey, that matches my number here, so don't add any lone pairs to the middle. But you can see sulfur has 6 domains around it. So we can circle the domains or count the domains. 1, 2, 3, 4, 5, 6. So something with 6 domains, it's called octahedral. And so that's an octahedral electron domain arrangement, but because each thing has an atom hooked to it, it's called an octahedral geometry. Okay, let's do BR F5. So BR will go in the middle. We'll hook 5 F's on it. 1, 2, 3, 4, 5. I forgot to count the thing. So there's 6 times 5. There's 35. Because there's 5 plus 1 is 6. Each has 7. So 7 times 5 is 35. And so then if we put the lone pairs on them, you can make sure everything on the all the outside elements should follow the octet rule in most cases. And so we got 6 times 5 is 30, 32, 34, 36, 38, 40. Oh, I must have counted wrong here. 5. Oh, 6. 6 times 7, that's not 35, that's 42. No wonder I counted wrong. All right, 42. Anyway, sorry if that confused you. Anyway, so then we count, there's 1, 2, 3, 4, 5 times 6, that's 30. 6 times 5 is 30, 32, 34, 36, 38, 40. But we're too short, so we're going to add a lone pair here. So there, that's 42. Now we can count our electron domains around the middle atom only. 1, 2, 3, 4, 5, 6. So we have 6 domains still, just like up above, except we're 1 atom less. There's one lone pair that doesn't have an atom on it. So minus, we're just going to say minus 1 atom off those 6 domains. And so 6 domains minus 1 atom, that's called square pyramidal. All right, the last one. Let's see if I can do better this time counting these up. So xenon has 8. Fluorine has 7 times 4, that's 28. 28 plus 8 is 36. Hopefully I counted right this time. A little rough on counting today. So Xe, we're going to put F, 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 F. I'm going to put lone pairs to satisfy the octet rule around the outside elements. So there, everything's getting 8 around it. Now the middle one, we'll just count, see how many we got, see how many lone pairs we got to add to the middle one. 2, 4, 6. Times 4 is 24, 26, 28, 30, 32. Well, I got to put a lone pair 34, 36. Now let's count the domains around the middle atom. 1, 2, 3, 4, 5, 6. Okay, so there's still 6 domains. So that's like an octahedral electron arrangement. But we got to find the geometry of the molecule. So we have 2 domains without atoms. So 6 domains minus 2 atoms. That's going to make a square planar. And when we build these molecules later here, you'll see how that works. Okay. All right. It kind of actually looks like it. Okay, that's it for this video.